Welcome to the Pro 50 chemistry class on solubility. In this topic, we suspected that at the end of this tutorial, candidates should be able to distinguish between the different types of solutions. They should be able to calculate the amount of solute that can dissolve in a given amount of solvent when the temperature is constant. So also expected that the candidate should be able to deduce that solubility is temperature dependent and also be able to interpret the different solubility curves. Candidates should also be able to classify the solvents based on their uses and also differentiate and compare between a true solution, a false solution of colloids, and a suspension. So this class is divided into 5 sections for easy comprehension. So section 1 talks about concept of solubility, the types of solubility, types of homogeneous solution and the factors affecting solubility. Section 2 is a bit of some calculations for the empirical formula for solubility and then the solubility product. Section 3 deals with temperature and solubility curves, how we can be able to deduce them. Section 4, we have solubility of gases and solvents. And then the last section, other types of solutions, like you've heard us mention the true solution, the false solution, suspension, etc. So, a solution is a homogeneous mixture of two or more substances. A mixture of two or more substances. So, in the jar below, in the diagram, it contains two substances. The number one is sodium chloride, represented as NaCl, and the other substance is H2O, water. So the mixture of both makes up a solution. We have the solute. It is the gas or liquid in which which dissolves in the solvent. The gas, liquid or solid, which dissolves in the solvent. From the last example, the solute is sodium chloride. Then the solvent is the liquid or solid that is present on a larger quantity in which the other substances dissolve. So the solvent in the homogeneous mixture we just saw is water. So water is usually regarded as a universal solvent because it dissolves most solutes. So in the diagram below, let's assume, like we did in the first example, in the first diagram, that the solute is sodium chloride, and then the solvent is water. So when you dissolve the solute in the solvent, you get a solution. Yes. So moving further, there are different types of homogeneous solution. Actually, there are 3, and they depend on the amount of solute that will dissolve in a given volume of a solvent at a particular temperature. So that determines the type of solution we're going to have. So the homogeneous solution can be classified into 3. Number 1, the unsaturated solution, the saturated solution, and the supersaturated solution. So let's see these 3 types of solution immediately. Saturated solution. It is a solution that contains as much solute as it can dissolve at that particular temperature. A solution with solute that dissolves until it is unable to dissolve anymore, leaving the undissolved substances at the bottom. So be mindful that the temperature we refer to is vital, since more solute can be added if the temperature is increased or if the volume of the solvent increases. So a little explanation. So let's assume also that what we have inside this container is solute, sodium chloride, and then the liquid is the solvent is water. Okay, so looking at the last jar, you could see that there are some particles of sodium chloride still remaining. What it means is that the solution is saturated. Most amount of solute has dissolved in the solvent until it's unable to dissolve anymore. So that's why it left some little particles down there. So very well, let's look at unsaturated solution. This is a solution that completely dissolves, leaving no remaining substances. A solution in which more solute could dissolve at a particular temperature. So it means that if you use the same example, you could see that in the third jar that it's as if there's no solute. Okay, because all the solute has dissolved and it still needs more. The solvent still needs more at the same temperature. While the supersaturated solution is that solution which contains more of the solute than it can normally hold at that temperature. It's a solution with more solute than the saturated solution. Contains more undissolved solute. So it means here that there is more sodium chloride, here, as you can see, than the solvent can contain. So it's when it is this way, we say that the solution is super saturated. So you either increase the temperature or increase the volume of the solvent, okay, in order to make all the solute to dissolve in the solvent. So increase the volume of solvent. So those are two options you have. So that's the basic definition. So a saturated solution, unsaturated solution. So with this knowledge, we define solubility as the maximum amount of solute in moles or grams that will dissolve in 1 dm cube of a solvent. The amount of solute that will saturate 1 dm cube of the solvent at that particular temperature. So there are 4 basic factors that affect the solubility of a solution. Number 1 is the nature of the solute dissolving in the solvent. The second one is the nature of the solvent in which the solute will dissolve, and then the given temperature at which the solute will dissolve in the solvent. If there are gases involved, as either the solute or the solvent, then pressure can affect the solubility of the solution.